Assalamualaikum, welcome back to my channel Learn with Your Buddy, and today I'm here with another video of our data structure series. And today we'll write a code on implementing deletion in a binary search tree using C++. Okay, so I have already written a code here and this is the output. Okay, so I'm not going to explain my code from here. I'm going to write it from the beginning and then we'll start the explanation line by line. Okay, so let me just cut it and I'll just select all of this by pressing Ctrl A, and then I'll press backspace. Okay, it's done. So now let's start with our header file. Okay, so we'll use for C++ include iostream. Now this includes the input output library which is needed for cout. So after that we will write using namespace std. Now this allows writing cout instead of std cout. Okay, so now after that we will take the structure of node. Now this creates a structure named node and each node represents one BST element. So yeah, then inside this we will write integer data. Now this stores the value of the node, and then we will write node star left. Now that's a pointer to the left child. Okay, so yeah, now after this I'll just copy and paste this in the next line and change the left into right. Now that's a pointer to the right child. So after that we will create a node function. Okay, now this is a function to create a new node that takes let me just write it. Okay, now it will take an integer value sorry, let me just cut this first bracket and I will just write the second bracket. Now it's done. Okay, so here then we are taking node star new node. Now the node star new node equals to new node. Now this dynamically creates memory for a new node, and then new node data equals to value. Now this stores the given value in the node, and then new node left. Now this means initially left and right child are empty, and then we have return new node. Now this returns the newly created node, and then we have the end of function. So after that we have node star find. Now it will find the minimum function, the smallest value in a subtree, and it will be used to get the Inorder Successor. Well, we have learned what is successor before in our last video. And then we will take a while loop. Now this will keep moving left until no more left child exists, and in BST smallest value is always on the far left. Okay, and then we have root equals to root left. Now this move root to the left child and then return root. Now this will return the minimum node. Then we will go to node deletion. Now this deletes a node from BST. Here root means current node and value means value to delete. So after that we will take if root equals to null. Here I made a mistake while writing null. Okay, I'll show this while running this code. Now here the if root equal to null means if the tree is empty it will return null. So after that we will write if value is root. Now this means if value is smaller it will go to the left subtree, and then we have root left. That's a recursive call on left child. Then we have else if. Now if the value is larger it will go to the right, and root left means recursive call on right child. And after that we are taking else. Now here in the else section it means if the value is root to data, now that means the node is found, and then we will take case 1 and 2, no child or one child. Here if root left equals to none, that means no left child exists, and then node temp equals to node root right, that means that will store the right child. After that delete root. Now this will delete delete the current node from memory, and then return temp. Now this will replace deleted node with right child. So after that we are taking else if root is equals to right, root right is equals to null. Now that means no right child exists, and then in the else if section we have no temp root left. Now this will store left child, and then delete root. Now this will delete the current node. After that we have node start temp. Now this is case 3, the case with two children. Now here it will find the smallest node in right subtree, and this is called Inorder Successor. And then we have root data is equals to temp data. Now this is a copy successor value into current node. Then we have root right equals to delete node. Now this will delete the duplicate node from right subtree, and then we have return root. Now this will return the updated. After that we are starting in order traversal. Well, here void in order. Now this prints a BST in sorted order, and if root equals to null, now this stops if node is empty, and then in order root left. Now this visits and then the cout root data. Now this prints the node value, and then in order root right. Now this visits the right subtree. So after that we are in our main function from where our program starts, and then we are taking the root node star root equals to null. Let me just write it at first, and then equals to null. Perhaps I have made a mistake. Let me just cut it. Okay, now it's done. Then it means the tree is initially empty. Okay, then after that we will create a tree. We will build a it will create a node. After that it will insert 30 to the left, and then 70 to the right, and 20 to the left. Left child's left, and then 40 to the left child's right. Then we have cout before deletion, or it will print before deletion. This will print a text, and then we have delete node. Now this deletes node 30. 30 has two children, 20 and 40, and the successor is 40. Then it will return, and our code is done. Now let's just run this. Here I can see that I have made a mistake here. Now here the null is in small letter, but now we need to write the null in block letter, so I'll just write it in the block letter. Change it again, ULL. Okay, so that's done. Now let's run it again. Again here you have null. This is the mistake I have said, I have talked about before. Then okay, here I have made maybe another mistake. Okay, here I need another, I need to cut this second bracket, and then in the main function, okay, it's again null. Now I need to change this into block letter. So yeah, here it is. Now let's run again. Let's see what happens. So yeah, here is our output. We had to delete 30, and then we have deleted 30 here. So I hope it's clear now, and that's all for today. If you guys find my videos useful, please like, share and subscribe my YouTube channel, and I'll see you guys in our next video with another new topic. So till then, stay safe, take care, keep practicing. Allah Hafiz.